Okay, so now we'll do some numericals related to mechanics of solid. Okay, I have given you the introduction on what is Young's modulus, what is shear modulus, what is bulk modulus, and I have told you what is stress strain diagram and what are the importance of different points in a stress strain diagram, what is yield point, what is proportional limit, what is ultimate tensile strength, what is breaking stress, and the strain energy stored in a wire if you apply a load on it. Okay, so this and okay, so we have a numerical. So let us say we will do this Pully numerical. Okay, so let us say so I have a pulley. Okay, and this. So I have a pulley. So I have two ropes hanging from this pulley. Okay. And so I have a pulley, and this weight is 3 kg. Okay, so this weight is 3 kg, right?
Yeah.
And
Other one is 5 kg.
other one is 5 kg. 5 kg. Both 3 kg are connected by a metal wire. So this is a metal wire. Okay, this is a metal wire. Normally the pulley wire will be made of metal because lot of load will be there.
Yeah.
So this is a metal wire. Okay. So metal wire going over a smooth pulley. There is no friction here. Okay, that is the meaning of a smooth pulley.
Yeah.
Okay, so the breaking stress of metal is the breaking stress. So the strength, that is the strength of metal. Okay, so metal, that is the strength. Okay. So stress you apply, strength is a property. Okay, so metal strength is equal to
24 by pi into 10 power 2.
okay, 24 by pi into 10 to the 2 Newton
per
per meter square. So that is the metal strength. Okay. What is the minimum radius of wire? Okay. The question is, what is the minimum radius of wire? Okay. Okay. So that is the question. Okay. So I can draw the free body diagram of the left side and right side mass. Okay. So if I draw the free body diagram of this 3 kg, so this is 3 kg. Okay. So this is my wire. Okay. So it will have a tension. Okay. It will have a tension, and it has a force W acting here, like is equal to 3 kg into 10.
30 Newton.
Huh?
30 Newton.
30 Newton. Okay, 3 kg into 10. Let me write it as mg. Okay, m1 into g, which is 3 into 10, right?
Yeah.
The Newton. Okay. And if I draw the free body diagram of the right side body, okay, so it is 5 kg. Okay, and here also this tension, this is tension T1. This is no tension will be common both sides. Tension is same, right? So this is tension, this is tension. Okay. This is 5 kg, and here you have weight acting is 5 kg into, so let us say, let me write it as m2 into g, which is 5 into 10. Let us say 50. Okay. So and when it is moving up, it is going at a acceleration a. Okay. And when it is moving down, it is coming down at a acceleration a. Okay. So with okay. Okay. So let me write it as 5G. Just let me write it as 3G here. Okay. Let me write it as 3G here, and let me write it as 5G here. Okay. So if I do the force balance, it will be like T minus 3G, right? T is acting upward, 3 is acting downward. T minus 3G is equal to T minus 3G is equal to 3 into A. Because this is the effective force. Okay, 3G is the weight, T is the tension. So the effective force is equal to mass into acceleration. So you know that net force is equal to mass into acceleration. So if you draw the free body of this, T minus 3G is equal to 5A, and if you draw this, T minus 5G is equal to 5A, right?
Yeah.
So now, okay. So T, this is T minus 5G. Okay. So because it is downward, so we can write it as like this. We can write it as 5G minus T, right? Because it is downward, right?
Yeah.
5G minus T is equal to 5G.
Oh, this is coming down, that is.
So that is T minus 3G is equal to 3A. Okay, 5G minus T is equal to 5A, and T minus
3G is equal to 3A.
3A. So this is equation 1, this is equation 2. Okay. So this, if we add these two, it will become 2G, right?
Yeah.
2G is equal to, if we add, it is 8A, right?
Yeah.
Okay, so your A is equal to G into 2 by 8 is equal to 4G. Okay. So finally you got your A is equal to
G by 4.
G by 4. G by 4. Okay. So your A is equal to G by
4. Yeah.
So once you get your acceleration as d by 4, then you can find out your tension. Okay. Once you find out the tension, you can find out the stress race and all. Okay.
Yeah.
Yeah. So okay. So now you know.
You have to substitute A as G by 4 and then find tension.
So T will then your T will become 3 into G plus A.
Yeah.
Right. Okay.
Yeah.
So 3 into G
plus G
by 4. Right. So your tension will become 3 into 5G by 4. So your T will become 15G by 4.
Yeah.
This is your tension. Okay. So now this is the force acting on this wire.
Yeah.
Okay. So let us say this is 150
by
4 Newton. Okay. Right?
Yeah.
So this is the force acting on the string. So the question is
radius.
The breaking strength is what is the minimum radius of the wire. Okay. So you know like
Young's modulus is given.
No, Young's modulus may not be required.
No, F by A is given.
So I know that my stress is equal to force by area. Okay. Force by area.
We know stress and we know force.
So this is nothing but instead of force you can write tension
by area,
and instead of
pi
area
r
you can write it pi by 4 d square.
You have to find r, so pi r square.
So sigma is equal to 150 by 4 divided by
pi r square. You have to find radius.
pi by 4 d square, that is equal to 24 by pi
10 power 2.
and 10 to power 2. So you have only one unknown here.
Which you have
So that will give you minimum radius of the wire. Why they are asking minimum radius? Because if you reduce the radius further down this, the stress will increase.
Oh.
So if it is a thin wire, your stress will be more.
Yeah.
You can understand, na?
Yeah.
If you are applying a load, a thin person it will be stressed more, na?
Yeah.
A thin structure, so a thick structure will have less stress. A thin structure will have more stress. So that's why it means what is the minimum thickness. If you lower the thickness below that, it will. I am equating with this.
So at least for that much strength, what is the radius?
Yeah, at least for that much diameter, this is the stress.
Yes.
And if you reduce the diameter below this, it will fail. Okay.
Understood.
So now by equating these two, you can find out what is the minimum diameter, right?
Yeah.
You can take a picture of this. Okay, so